Welcome to today's tutorial, and in our tutorial today we are going to focus on the determinant of a 2 by 2 matrix. So under this determinant of a 2 by 2 matrix, we are going to look at how to calculate the determinant of a 2 by 2 matrix. Then from there we'll also look at one or two examples. Then we can be able to look at the inverse of a 2 by 2 matrix. So given that matrix Q is equal to A, B, C, and D. Now, these are elements, okay? These are elements that are given for matrix Q, which is A, B, C, and D, okay? Then the determinant of this matrix can be calculated as the product of the major diagonal, okay? Product of the major diagonal minus the product of the minor diagonal. The minor diagonal, okay? So now, when we talk about the major and the minor diagonal, we need to understand what are we talking about, okay? This is what we call as the major diagonal, the C, so the A and the D. It's what we call as the major diagonal. Then this, which is highlighted in yellow, is what we call as the minor diagonal. So if a question tells us to calculate the determinant, it means that we're going to find the product of the major diagonal and then the product of the minor diagonal. So therefore here we can say that the determinant of matrix Q is equal to A multiplied by D, okay, minus B multiplied by C. So the determinant of that matrix will be equal to AD minus BD minus BC, sorry. Okay, so if we have AD minus BC representing the determinant, okay, of a 2 by 2 matrix, we can now look at an example. So how do we find this? Given that matrix Q is equal to 3, 4, -5, -2, okay, then the determinant of that matrix Q will be equal to 3 multiplied by 4 minus -2 multiplied by -5, okay, -2 multiplied by -5. So 3 multiplied by 4, that is 12. Then -2 multiplied by -5, that is 10. Okay, so our answer there is going to be +2 as our determinant for the 2 by 2 matrix. Okay, we continue. We'll look at an example now. given that P is equals to 3, -1, -2, and a 0, okay, and Q is equal to 3, 4, -4, and an X. We are told now to find the value of X if P and Q have equal determinants. Okay, equal determinants. So how do we solve such a question? The key there is the equal determinant. So that basically tells us that the determinant of matrix P is equal to the determinant of matrix Q. Okay, so meaning that your major diagonal, which is 3 multiplied by 0, minus your minor diagonal, which is -1 multiplied by -2, would be equal to your major diagonal, which is 3 times x, minus your minor diagonal, which is 4 multiplied by -4. Okay, so 3 multiplied by 0, that is 0, minus -1 multiplied by -2, that's a 2 there, and 3 multiplied by x, that would be 3x, minus -4 multiplied by 4, that is -16. So negative multiplied by negative there to give us a positive. So 0 minus 2 mean -2 there being equal to 3x. Negative and negative is giving us a positive 16 there. So you put the like terms together. We are told that whenever a number crosses an equal sign, the sign of operation does what? It changes. If it was a negative, it's going to be a positive. And if it was a positive, it's going to be a negative. So when this -16 crosses the equal sign, to be -2 minus 16 being equal to 3x. So -2 minus 16, that's going to give us -18 being equal to 3 what? X. You divide both sides by 3. Okay. Your x there is going to be equal to -6. Okay. So once we're done that one, we can now look at the inverse of a 2 by 2 matrix. Okay. How do we find the inverse? We can't find the inverse minus finding the determinant of a 2 by 2 matrix. So whenever you are finding an inverse, the first step is for us to find the determinant of a 2 by 2 matrix. Okay, so let's look at how we can be able to calculate the inverse, which is denoted by that symbol there. That is the matrix. If the matrix is P, it will be P with that -1 on top there. So, given that matrix Q is equal to A, B, C, and D, the first thing that we have to do is for us to find the determinant, where we said it will be A multiplied by D minus B multiplied by C. Okay, AD, A multiplied by D, that is AD, minus B multiplied by C, that is BC. Okay, so after we find the determinant there, we can now go to the inverse, where we shall say the inverse here is equal to 1 over determinant. Now follow me very well. These numbers that are in the major diagonal, the A and the D, they interchange. Meaning here we're going to have a D, here we're going to have an A. And the numbers that are in the minor diagonal, they just change the sign. Meaning this would be negative C, and the other one is going to be negative B. If it was positive, meaning it's supposed to be negative. If it was negative, meaning it's supposed to be what? Positive. And that means you would have found your what? Your determinant. Sorry, your inverse, sorry. So let's look at a numerical example. For example, if matrix Q is 3, negative 2, negative 5, and 4, how do we find the inverse? The first thing that we're supposed to do in this case is for us to find the determinant, okay? Of which the determinant in this case will be calculated as 3 multiplied by 4 minus negative 2 multiplied by negative 5. So that will be det of this matrix. It will be 12 minus 10 there, and our determinant is going to be 2. Now, we said that inverse, it is 1 over determinant over det, okay? So, the element in the major diagonal, meaning the 3 and the 4, they're going to interchange. We're going to have a 4 there, and we're going to have a 3 there. Okay? They have interchanged. But what happens to elements in the minor diagonal, which is negative 5 and negative 2? Those elements, they will change the sign. If a number is a negative, it will be a positive. And if it is a negative also, it's going to be a positive. Okay? But if one was a negative, it would have changed to be, if one was a positive, it would have changed to be a negative. So this element now, or this set that we have of numbers here, is what we call as the adjoint. So therefore, our inverse is going to be equal to 1 over, the determinant is 2, going to say 4 there, 2 there, and 5, then 3. Others, you can leave it there. But if it becomes a challenge, you can multiply. We are going to say the inverse of this matrix, 1 over 2 multiplied by 4, that is equal to 2. 1 over 2 multiplied by 2 again, that is 1. Then 1 over 2 multiplied by 5, it's 5 over 2. 1 over 2 multiplied by 3, that will be 3 over 2. And that becomes our inverse. Okay. So we can now look at an example which is coming from an examination paper. Example. So given that matrix A is equal to 7, 4p, then 9, then 5p. Okay. Then find the value of P for which a determinant of A is -2. The next says, hence, find the inverse of A. So here I've been given the determinant already. So what do we do? Solutions. We're going to say that determinant of A is equal to 7 multiplied by 5p minus 4p multiplied by 9. So the determinant of A will been given to be -2, being equal to 7 multiplied by 5p. It's going to give us 35p minus 4p multiplied by 9. That's going to give us 36p. If you subtract there, it's going to be equal to -p. You divide by negative on both sides. Okay? So the value of p there will be equal to 2. So now that you find p to be equal to 2, you substitute the p in the matrix so that you can be able to find the numerical values. Okay? So meaning A there is going to be equal to 7, 9. So here it is 4 multiplied by the 2, which is the p. Then here it will be 5 multiplied by the 2, which is the p. So matrix A in general, it is equal to 7, 9 here, and 2 multiplied by 4, that's going to be equal to 8. 2 multiplied by 5, that's going to be equal to 10. So that is your matrix. Okay, so when finding the inverse, we know what's going to change. Okay, so how do we find the inverse of that matrix? I told there the inverse of A is going to be equal to, our 10 becomes there, our 7 will be here. Then the 9 and the 8 there, as you can see, they're just going to change the sign because all of them, they are positive. So they're going to be what? Negative, which is going to be equal to -8 and -9. Okay, so remember that is 1 over det, then the adjoint. So here we shall say 1 over -2 there. That's our determinant. It's going to be 10, -8, -9, and the 7. Okay, so our inverse to 1 over 2 multiplied by 10, that's -5. -1 over 2 multiplied by 8, that is a 4. -1 over 2 multiplied by -9, that is 9 over 2. Then -1 over 2 multiplied by 7, that will be -7 over what? Over 2. Okay, like that.